Well, howdy students. This is going to be a video that talks about how light is also a particle, and we have an equation that we're actually going to be using to calculate the energy of those particles. So a man named Einstein, perhaps you've heard of him, proposed that electromagnetic radiation can be viewed as particles. So not only do we have light behaving like a wave, we also have it behaving like a particle. His famous equation, E equals mc squared, helped to determine the amount of energy released as radiation from a certain mass. So that's what Einstein was famous for. Max Planck was a buddy of his, believed that energy was emitted or absorbed by small units called quanta, which is where eventually we get quantum mechanical model. He found that the amount of energy released or absorbed was proportional to the frequency of the radiation. The equation here is E equals h times v, and we can actually get a triangle out of this guy. And E is going to be on top, h is Planck's constant, and v is frequency. I'm going to go ahead and write in the units for energy here. Energy is in joules, which is capital J, spelled Joules. Frequency, we saw in the previous equation when light was behaving like a wave, and that was hertz, or 1/2, or seconds inverse. Planck's constant is kind of a funky number, but it's just a number, 6.63 times 10 to the negative 34. That's a very small number. And that's joules times seconds. And that's for seconds. Einstein proposed that light could be viewed as a stream of particles called photons. So let's apply this equation here. Calculate the energy of an individual photon of yellow light having a frequency of 2.73 times 10 to the 16th hertz. Okay, well, step one, we need to find our equation. There it is. We're calculating the energy, so we don't need to rearrange it. But just to show you, E would be on top, H and V. I'm solving for E, so it'll be H times V, which we have. We know Planck's constant to be 6.63 times 10 to the negative 34 joule seconds. And we're going to multiply that by the frequency given here. And when we do that, the final answer is 1.81 times 10 to the negative 17th joules. A quick word on units. We have joule seconds, and we're multiplying it by 1/seconds. So what we get is joules in seconds over seconds. And what we know of units can cancel out top and bottom, and we are left with joules. So it makes sense that we have joules there.